see a little bit of reading about speed. It's a short little bit of reading about speed, and it talks about instantaneous speed and average speed. I'd like you to go ahead and read that PDF that's there on Nearpod. I'm going to give you a few minutes to do that by yourself, and then in a minute I'm going to ask you some questions about it. So go ahead and read that thing on your Nearpod. And for those of you who are joining us on...
Hey, it's taking mine a second to load, so...
Okay, yeah, that's fine. But for those of you who are joining us on the recording, I have included a link to this on Schoology, so you can read the PDF on Schoology. On this next slide here is I'd like you to tell me, based upon your reading there, what did you learn? What important things did you learn about speed from that reading? So I'd like everyone to share something in that little, where it says share thoughts or images there. Here, I'd like everyone to sort of type something there that they learned about speed. For those of you just joining us maybe, I'm posting the link again in chat where you need to log in to Nearpod to participate with us.
My invalid message.
I'm sorry, you can't see.
It's my computer's being stupid.
All right, well, give it a minute and see if it comes.
Nearpod.com, sent an invalid response.
So that's what happens when you click the link that's on the chat?
There we go.
All right.
I'm just refreshing a few times.
Good. So again, I'd like everyone to go ahead and enter something in where it says share thoughts or images here. I'd like you to share something in there. All right, good. So I got speed equals distance over time. Good. Speed is the distance something can travel in a certain amount of time. We use the slash, like if we have meters / seconds, it's going to mean per. That's a good thing. Can anyone share in there something about the difference between average speed and instantaneous speed? So hopefully I can have somebody share something about the difference between average and instantaneous speed. Anyone got anything about that? So I want to look here at what Nate said, right? Speed is measured by the amount of time, by the amount of distance traveled over a time period. If we talk about that definition is going to be the definition of average speed, right? Average speed just means whatever distance you traveled divided by whatever time it took you to do that, right? But within that average time period, you can have different instantaneous speeds, right? Instantaneous speed is just what your speed is in that instant. So your instantaneous speed can be constantly changing, but you would only have one average speed for a given amount of time. All right, so with that in mind, I'm going to go to the next slide. And the next slide, I'm going to ask you to explain the difference between average and instantaneous speed. So I want you to try your best, given what we just talked about, to explain the difference between average and instantaneous speed. If you need to look back there, I've included a link to the PDF. But I want you to go and answer this question, and then you can press submit when you've answered it, and then I'll be able to see your response after that. So I'm going to go ahead and share Austin's answer here, right? So instantaneous speed is at any given time it can change, but the average speed is between one place and another. So I like that. So that's one way of thinking about it. I'm going to share another one here. Instantaneous speed is how fast you're traveling in the instant. Average speed is the average of how fast you're going over a period of time. All right, so this is good. Now, one thing I want to be clear about when we say average, it's not average in the same way as we were talking about average last unit, right? It's not average in the sense that you are adding things up and then dividing by the number of things that you have. it's more like an average, like it's more similar to when we were doing a best fit line, where you were kind of taking a bunch of points and saying on average, this is what it seems to say. So a way of thinking about average speed is if you traveled at the average speed the entire time, you would make it to your destination in the same amount of time. It's one way of thinking about it. All right, that's a little bit confusing, but to kind of maybe think about it a little bit differently, I'm going to ask another question. So you travel 40 kilometers in a half hour. What do you think your speed is? So go ahead and calculate out what you think your speed should be. And is that average, is that speed that you calculated, is that your average speed or is that your instantaneous speed? And why do you think that? Looks like we're in, at very least, we're in agreement that it's 80 kilometers per hour. So I agree it's 80 kilometers per hour. We're in a little bit of disagreement about whether that's the average or whether it's the instantaneous. I'm going to say it's the average, and I'm going to share Nate's answer here because I think that it's a good explanation. It's the average because it's measured after the whole distance and the whole time, right? Whenever you take an individual distance divided by an individual time, that's going to be your average speed. The instantaneous speed you'd have to have something like a speedometer reading the speed for you. So I'm going to say yes, that's an average speed. Okay, next thing we're going to do is this one's a lot shorter of a reading, but I want you to read about velocity. So I'm going to give you a few minutes here to just read that short reading to yourself. All right, I'm going to go ahead and go to the next slide, and I'm going to ask you to, again, share with me something that you learned about velocity. I'm specifically interested in, can you tell me what makes speed different than velocity? I don't know what it's doing on your screen, but right now mine's loading, so we'll give it a second here. Well, let's try that again. There we go. All right, so what makes velocity different than speed? So yeah, I think at least of what I'm seeing so far, right? Velocity is speed and what direction, right? So the key difference is that velocity includes direction, whereas speed does not. That's the key difference. Okay, so with that in mind, here I've got, let me give it a second for it to load, but basically the question is going to be, I'm going to have a car on a circular track. And the car on a circular track may have a constant speed, but even if it has a constant speed, we're going to say that its velocity is changing. So what I'd like you to do is I'd like you to try and explain to me, even though I'm going at a constant speed, why is it that velocity is changing at every instant? So explain that there. And make sure to click submit when you're done. All right. Yeah. So it looks like, yeah, the key here is, right, the direction is changing. So even though the speed is constant, right, the velocity is changing at every distance because it's the direction that's changing. Velocity is speed and direction. All right. Real quick, the acceleration reading is not that long either. So I'm going to give you a few minutes here to do the acceleration reading. All right, so I'm going to go ahead and go to the next slide now and ask you to share what are some important things about acceleration that you learned from that reading. Go ahead. I'd like everyone to try and enter at least one thought in that box there at the bottom. All right, let's see here. Acceleration equals change in velocity over time interval. So that's the equation. Good. Acceleration is gradually getting faster and faster, but not only getting faster and faster, right? It'd be any change in speed. Acceleration is the decreasing of your speed over a certain amount of time. So yeah, so it's either increasing or decreasing your speed. You can accelerate. So I want to talk about this one here. I don't know if you can. The one that I just put. You guys can't see which one it is, I think. But the one that says acceleration can change even if you have a constant speed, right? What would you have to be doing if you wanted to have a constant speed but still be accelerating, right? Well, if acceleration is change in velocity, what you need to be doing is you need to be changing direction. So you'd have to be turning or something. All right. So with that in mind, and I want this this question, we haven't explicitly answered it, but I want to see how you can do on it. There are 3 ways to accelerate. I want you to see if you can come up with what are the 3 ways that you can accelerate. So we'll give it a second. It's still loading. So there are 3 ways to accelerate. What are they? And if you can't get 3, get as many as you can. And we'll talk about it in a second. Again, when I'm grading this, I'm not so much looking for correctness as I am looking that you've made an attempt.
Hey, mine just closed down by
Say
my
again.
whole Google just closed for me.
Who is saying Leighton?
Yeah.
Okay. Well, if you, I'm gonna put the link in. I'll just know when I'm looking at it that you started, that it'll be in 2 different ones. But I just put the link again in the chat. You can come back in.
Okay. Thank you.
Yeah. All right. So what do we have? Change in velocity, change in direction, or change in both velocity and direction. That's a good way of saying it. Speed up, slow down. So those are 2, definitely. So the way that I was thinking about it was, it looks like Nate got here. Speed up, slow down, and change direction, right? Because again, velocity is speed and direction. So if I change either of those things, that's considered acceleration. If I speed up, if I slow down, or I change a direction, those are all ways to accelerate. Okay. Next question. A particular car can go from rest. Oh, you can't see that yet. Just a second. Loading, loading, loading. Let's see here. Come on now. Here we go. So a particular car can go from rest to 40 meters per second in 5 seconds. What do you think its acceleration is? So see if you can calculate its acceleration. It looks like we're pretty much in agreement that it's 8, right? So 40 divided by 5 is 8. So, and the unit that I'm actually going to give it, so we're going to call it 8. It's changing by 8 meters per second every second. So the unit we're actually going to use is 8 meters per second per second. And sometimes you'll hear me, and in class we'll talk about this more, but sometimes you'll hear me abbreviate that as 8 meters per second squared. All right, one more here. And then we'll go into a check for understanding. So let me wait for it to load. You had a constant speed of 95 meters per second. What is its acceleration? See if you can calculate out your acceleration. Good. So some of you got this here right. So the idea is the key word in this question is constant. If I'm going at a constant speed of 95 meters per second, that means I am not accelerating, right? So if you're going at a constant speed, and assuming you're at least going in a straight line, right, there's no acceleration, because to accelerate, you have to have a change in speed or a change in velocity. All right, we're going to end with a few check for understanding questions. I've got these set up as polls. So again, there are right and wrong answers, but I'm not grading you on right and wrong. I just want to see what you think. So the first question here is